Hello. So let's talk about the motor of the Gillett Phonograph. After the first test I did, it works. It has just enough power, but I don't like it at all. Why I don't like it at all? Because it's noisy, and it needs the power is just enough. Everything must be perfect to work, and I cannot sell these machines to overseas owners that are going to get shipped this machine thousands of kilometers away, just to see that the lifespan of the brushes are about 5 to 10 hours. It's noisy, and if something is not absolutely perfect, it doesn't work as it should. So add to that the Gillett phonograph that is in a collection in the United Kingdom has a completely different motor from I think it should be a air ventilator or something like that. And surprise, surprise, we have found another Gillett phonograph built in that era in Australia. I will write about that later, maybe next week. Um, Surprise, surprise again, that Gillett phonograph, Gillett based phonograph, when it was found, it was without motor. And the owner, that is family of the builder, have been able to trace all the story of the phonograph. He's an electric engineer, and he did a replica of it, and he says that it works, but it's noisy. You have modified the brushes, have put soft copper brushes like the ones used on the slot cars, and even with that, he's not very happy about the motor. So I decided to modify it, but not modify it in any modern way. Just to I decided to take the best practices of the era and to implement them on this motor. On the English Mechanic in the English Mechanic magazine, when Gillette was publishing these blueprints and articles, there was also a guy called Celino Romeo Bottone that was also an electric engineer that he answered a lot of questions about the motor and uh, and how to troubleshoot it. And I was very surprised when I found that he also was a writer, and he wrote lots of books about electricity. So I took his books, I found them, I printed them because now you cannot find them printed, and they are no longer copyrighted, so you can just download them from Google and print them. And I spent this summer vacation studying them. It has these three ones: electrical instrument making for amateurs, Celino Romeo Bottone; the dynamo. By the way, a dynamo and a motor are exactly the same thing. If you have this and you put electricity, it turns. If instead of putting electricity, you just turn the rotor, you produce electricity. Okay, it's perfectly reversible. So whatever you learn for a dynamo, you learn for a motor. And the electromotors, how made and how used, also by Celino Romeo Bottone. And I found several very, very interesting things. Let's go just to the very, very basic things. First of all, the intensity of the electric and magnetic fields. You know, a motor, what it does, and if you don't know, I will explain it to you. Never mind. A motor consists basically on two parts. An electromagnet. These are two coils that create a very powerful magnetic field, north and south. And you have a rotor in which you apply some current, so you apply to different segments alternatively of the rotor a magnetic current, so they create a magnetic field. So with the brushes, when you put, for example, electricity here and here, you have north pole here, south pole here, and this is the north and this is the south, so it turns to come here. But when they arrive here, now there are those ones who have changed the polarity, and it turns and it turns and it turns, so on, so forth. So the distance, the intensity of the electricity, of the electric and magnetic effects is directly intense as the square of the nearness. So as closer as possible should be the rotor to the electromagnet. And by the rotor, we are not talking about the copper. We are talking about the interior. The rotor consists of several rings like this. I will explain later why there are rings and not a thick piece of thick ring that turns here. This is what gets magnetized. So let me try to put it here so you can see how close or how far this ring is from the magnets. It's about 5 millimeters, 5 to 6 millimeters. Okay? It doesn't look too close. Let's continue studying. Then he says something that is not true, but I just highlighted it because it was fun. Say that it would appear that in case of the electromagnets, the ratio between the distance and the effect increases even more rapidly, according to the best authorities, equal to inversely the cube of the distance nearby. That's not true. It's the square. Okay, science have evolved and have measured it accurately as is the square of the distance. Okay. So what Mr. Bottone suggested to decrease that distance between the electromagnets and the and the and the rotor. He suggested to make the rotor with some cogs. Okay, projected teeth of or cogs of the Pacinotti form to increase the efficiency of the dynamo from 30 to 50%. So we can almost, even if we believe not too much these numbers, we can increase almost by twice the efficiency of the dynamo or the efficiency of the motor. Okay, even at 25% will be a great efficiency. So that's what I did. Instead of using this kind of rings, what I'm going to do is to use this kind of rings with cogs. I have 6 coils, so 6 cogs. Then you might be wondering, look, here you can see it, okay? Exactly the same as I show you on the motor. Then he speaks about the Manchester kind of motor, Manchester type motor. Manchester is the only, I have searched low and below on the internet for a Manchester dynamo or a Manchester motor, and here is the only place that I have found it, apart from what on the Gillett book. Okay, so the Manchester motor should be using this kind. of rotor with cogs or pegs. He said that the lamination should be stamped out of good charcoal sheet iron. Why charcoal sheet iron? Let me tell you why. Whatever iron that is not sweet iron or charcoal iron, when it gets magnetized, it retains some part of that magnetism. So, as I told you before, when this turns, the polarity of the magnet changes. So you have to demagnetize it and remagnetize it on the other side. So, if you are retaining some of those magnetic force, the power you need more power to eliminate it and then create it again. Soft iron or sweet iron is also called, or charcoal iron, does not retain any magnetism, so it gets magnetized and demagnetized instantly. You have seen this effect surely on the screwdrivers. The screwdriver, when it touches a magnet, then the screws attach to the screwdriver, whatever you do, and it's very difficult to remove that magnetic field. Okay, if you have a screwdriver made of soft iron, you will not have this problem. But the problem is that this is very soft, so it will bend, it will twist, and it will not be useful. There's always a trade. So why these laminations? These laminations, another book explains why. It's because of the Foucault or eddy currents. What are those eddy currents? Eddy currents, let's put a thick, imagine this is a thick solid piece of iron, okay? So this is what is rotating, and it's not in laminations. It's just a plain ring. So we will have this cross section. Eddy currents turn inside the core of this, and they are creating magnetic fields that interfere with the outside magnetic field. So you need more power to counteract those ones. These fields are directly proportional of the intensity of the magnetic flux, the intensity of the magnetic force, the EMF, the frequency, the polarity changes, and the thickness of the material. So by doing the rotor with thin laminations, you end up with this kind of cross-section, and the eddy currents are very little inside each lamination. And you have also to lacquer the lamination so that they don't touch each other. They are insulated from each other. So that's one of the modifications I'm going to do. And the other one are the brushes. Mr. Bottone, he says that this kind of commutator is noisy, it's subject to a lot of wear and problems, because you need the exact force in order not to be too weak or too strong or create sparks. So it's very difficult. And one of the main problems is that because the angular speed is very high, you are too much apart from that. Okay. So and there's very little room to make this spring enough to touch, but not too hard to erode, and so it's absolutely a nightmare to set it properly. So he suggests to use this kind of brushes that are on a drum like this, like what we are used to see in modern motors. And I have found that these drums can be made So what I'm going to do is, instead of using an horizontal commutator, I will use a drum commutator with brushes that goes like this. Okay, so longer, so you can tweak the stiffness of the brushes much better, and they will touch like this. And that's it. That's what I'm going to do this weeks, and you will very soon see the final version working of the Gillett motor. Thank you for your attention. Bye.